so I want to talk a little bit about electromagnetic induction. And this is kind of implicit in the terminology that's used, but basically the point that I want to make is that anytime you have electrons moving through a conductor, a magnetic field is generated. So what that means is that actually any current carrying wire also has a magnetic field. So any current carrying wire actually has a magnetic field. And the magnetic field that's generated is going to be perpendicular to the direction of the flow of current. So actually, we can predict the directionality of the magnetic field if we know the directionality of the current, and vice versa. Magnetic field if we know the direction of the current. So I'm going to teach you a trick. So we're going to figure it out using something called the right-hand rule. Okay, so let's say we have a current carrying wire. So I'm going to draw a current carrying wire. So let's say that the current I is traveling up this wire. So we know the direction of our current. Well, based on the right-hand rule, if I point my thumb in the direction, my right thumb it has to be, if I point my thumb in the direction of the conventional current, I, so I'm going to point my thumb upward, then my fingers will wrap around the wire in the direction of the magnetic field. So what you'll notice is if the current is traveling up the wire, my thumb is pointed up, which means that my fingers wrap around. It would be as though my fingers are going into the page and then coming out of the page. That's how they'll wrap around. Okay, so the way it would look over here is the magnetic field would be going into the page and then coming out of the page like this. And I'm going to label my magnetic field with the letter B, variable B. So B represents the magnetic field. And I represents the direction of conventional current. Well, when I'm talking about conventional current, I'm not talking about electrons. I'm talking about protons. Okay, so actually, which way in this diagram are our electrons flowing? Well, if our protons are going up, we know that our electrons must be going down. Okay, so right hand rule, let's just make a note to ourselves. We use our right hand. The right thumb points in the direction of conventional current, I, not our electrons, points in the direction of conventional current. And our fingers wrap around in the direction of the magnetic field. So sometimes we're actually going to use these symbols to represent into the page or out of the page, because as you can see, and as we said before, that the magnetic field is always perpendicular to the direction of current, right? So current is flowing along our y plane, and the magnetic field you can see coming out through our z plane. Okay, assuming if this was in 3 dimensions. So as we said before, based on our right hand rule, current is going up, the magnetic field, let's pretend this Sharpie is the wire, the current carrying wire. So our current is going up, our fingers are going into the page, and then coming out of the page. So we would represent that magnetic field as having as having X's on this side. X's mean into the page, and dots on this side, which means coming out of the page. Okay, so this is showing us the direction of that magnetic field. X's means into the page, and dots mean out of the page. And that is telling us the directionality of our magnetic field around this current carrying wire, which I'm just going to color in red. So here's our current carrying wire. And because there's current running through it, it's generating a magnetic field perpendicular to that, as is depicted by the X's of the field going into the page and the dots, which represent the magnetic field coming out of the page.